Welcome, everyone. Whether you're a manufacturing executive, an industrial engineer, an investor, or leading AI strategy, to this executive briefing. Today, we're taking a deep dive into the true, often completely invisible infrastructure battle behind modern robotics. You know, every single week, the financial headlines are shouting about a new humanoid robot, a breakthrough AI model, or some robotic startup pulling in massive capital investments. But here's the thing. If we only focus on the robots themselves, we risk completely misunderstanding where long-term competitive advantage is actually being built. So let's dive right in and uncover the real foundations of the next industrial era. The race for physical AI won't be won by the best robot. Now, I know that might sound completely counterintuitive. When most of us think about the robot race, we immediately picture these sleek humanoid machines walking the factory floor or autonomously sorting packages in a massive warehouse. But evaluating the space from that angle, that is looking at the wrong starting line entirely. The real competition actually begins years earlier, with advanced semiconductors, AI computing infrastructure, manufacturing capabilities, and the incredibly complex ability to connect all of those components into one seamlessly integrated system. And Earth industrial leadership is built on foundational infrastructure, not just a standalone mechanical product. Here is the roadmap for today's explainer. First, we'll look beyond the robot race. Then we'll map out the physical AI stack, followed by a deep dive into Samsung's integrated ecosystem. After that, we'll unpack the industrial data flywheel, analyze the competitive landscape, and finally, lay out the 5-year outlook.
All right, Section 1, Beyond the Robot Race. Let's talk about shifting our analytical framework.
To truly grasp what's happening in this sector right now, we have to fundamentally change how we analyze these companies. Evaluating robotics as if they were just standalone consumer products completely misses the massive industrial transformation happening right beneath the surface. So let's set our baseline. What exactly is physical AI? By definition, it's AI systems capable of perceiving, reasoning, and acting within the physical world. For the first generation of AI, the focus was entirely digital, right? Search engines, large language models, recommendation algorithms. But physical AI takes artificial intelligence out of those digital data centers and drops it directly into factories, warehouses, hospitals, and eventually our living rooms. Instead of just answering text prompts, the AI is now performing actual physical work. And to put that scale into perspective for you, while a digital AI might process millions of text tokens, a physical AI in a modern smart factory is processing gigabytes of real-time spatial and sensory data every single minute. It is a completely different ballgame. And that shift in scale perfectly illustrates why we need a new analytical framework. Look at a product-focused analysis. This is where the broader market usually sits. They evaluate a robot in isolation, basing its entire value on hardware specs, payload capacities, or mechanical agility. We really need to dismiss that limited view. Instead, we need an ecosystem-focused analysis. This evaluates the massive infrastructure, the compute, the memory, and the real-world data deployment behind the machine. The crucial takeaway here is that an enduring competitive advantage comes from owning the entire interconnected system, not just the mechanical shell it comes wrapped in. Moving on to Section 2, the physical AI stack. Let's look at how we build this intelligence from the ground up. You can think of this as the iceberg architecture. The robot you actually see in the factory is just the visible tip of a deep, highly complex technological dependency chain. You simply can't have the robot without the layers beneath it. So let's walk through these sequential, hidden layers. First up, compute. Modern robots require absolutely enormous processing performance to analyze dynamic environments in real time. Second is memory. High bandwidth memory, or HBM, is absolutely critical here because modern AI workloads require moving data at unprecedented, sustained speeds. Third, vision. A robot can't act intelligently if it's blind. This requires advanced CMOS image sensors and depth estimation technologies. Fourth is the AI itself. That's the foundational reasoning and spatial planning layer. And finally, number 5, manufacturing. This is the physical execution layer, where those digital decisions become tangible physical actions. All of these layers logically and functionally rely on one another to make physical AI a reality. Which brings us to Section 3, Samsung's integrated ecosystem, leveraging decades of industrial assets. Now, this is where we pivot to Samsung's highly unique position in the market. Most companies trying to enter the robotics space have to piece an ecosystem together from the outside. They're buying software, licensing operating systems, and partnering up for hardware. But Samsung? They aren't building a robotics ecosystem from scratch. They are connecting decades of existing world-class industrial assets.
Just look at these strategic domains. They have advanced semiconductor fabrication to provide that massive compute we talked about. They're already a global leader in high-bandwidth memory to feed those data-hungry AI models. They produce world-class CMOS image sensors and time-of-flight sensors, basically providing the vital eyes for the robots. They have massive smart home platforms for consumer connectivity down the line. And of course, they possess vast global manufacturing operations. So instead of trying to invent a new industry from absolute zero, Samsung's strategic opportunity is in orchestrating these formidable, pre-existing building blocks into one unified platform.
And you definitely want to pay attention to this number, 35%. That is Samsung's consolidated ownership stake in Rainbow Robotics, which is a company with deep, proven experience in humanoid, collaborative, and quadruped robots. Alongside this, Samsung has also made targeted strategic investments in companies like 1X Technologies, who are developing highly dexterous robotic hands. So why does this matter to the big picture? Because while Samsung already owns the underlying compute, memory, and sensors, these targeted investments secure the physical hardware and motion control layers. They are actively acquiring the final mechanical pieces of the puzzle to complete the whole shebang.
Which leads us to an absolutely crucial point. Infrastructure ownership creates a long-term strategic advantage by turning factories into living laboratories. Think about it. Most robotics startups spend years begging for a pilot program, just desperately trying to convince a customer to let them test a prototype on a real factory floor. Samsung doesn't have that problem at all. Their greatest strength is their internal deployment capability. They can use their own semiconductor fabs, their consumer electronics assembly plants, and their global logistics centers to ruthlessly test, validate, and flawlessly refine robotic systems behind closed doors, long before they ever attempt to sell them commercially.
Let's move to Section 4, the industrial data flywheel, the ultimate moat. We are rapidly moving from hardware as the main differentiator to operational learning. And operational learning is arguably the most defensible asset a company can possess in this new era. I want you to really think about this question for a second. Why is operational experience the ultimate moat? Well, hardware can eventually be reverse engineered, right? A well-funded competitor can just buy the exact same manufacturing machines or poach your talented engineers. But what they absolutely cannot instantly replicate is the accumulated industrial history and real-world operational data embedded deep within another company's systems. You can't just go online and download physical friction models, material behavior anomalies, or long-term equipment degradation patterns. That data has to be experienced, recorded, and processed over millions of grueling operational hours. And that process builds into an incredibly powerful, self-reinforcing loop. Step 1, internal deployment across Samsung's vast global facilities. Step 2, that deployment generates massive amounts of real-world data. I'm talking every microscopic robotic movement, every automated quality inspection, every single predictive maintenance event being recorded. Step 3, that proprietary data continuously trains and creates better AI models. And finally, step 4, those optimized models get pushed right back down to the factory floor, leading to improved operations, which of course generates even more high-quality operational data. Companies capable of building this industrial data flywheel develop advantages that just become exponentially harder for competitors to catch up with over time. Section 5, the competitive landscape. Because again, we're evaluating ecosystems, not just products. Make no mistake, Samsung is entering a race where competitors possess vastly different yet highly formidable strategic advantages. We aren't just comparing standalone robots, we're analyzing competing industrial ecosystems. If we systematically break down this landscape, you'll see NVIDIA absolutely dominates the compute and AI software foundation layer. Siemens is a total powerhouse in industrial software and digital twin technology, essentially digitizing the entire factory floor. Tesla has an undeniable moat when it comes to real-world mobility data and vertical integration. And Amazon leads the world in massive-scale warehouse robotics and highly optimized logistics. But look closely at Samsung's position here. While they might not lead every single individual category, their unique edge is their horizontal integration. They span across advanced compute, memory leadership, and machine vision, while also possessing massive global manufacturing infrastructure. Their potential advantage comes from orchestrating an entire ecosystem rather than strict, isolated specialization.
Let's wrap up with Section 6, the 5-year outlook, opportunities, risks, and the key indicators you need to watch. The next 5 years are going to be absolutely critical. They'll likely determine if physical AI actually becomes a unified industrial platform, or if it just remains a collection of isolated, disconnected technologies. If you're an executive or an investor tuning into this, you need to look way beyond those headline-grabbing, flashy product launches. Instead, you need to be monitoring the structural indicators.
Watch for Samsung's ongoing investments in AI computing infrastructure. Look for signs of accelerated automation inside their own global factories. Keep an eye out for new strategic partnerships in software and industrial automation. And most importantly, observe if AI is being seamlessly integrated into their broader business strategy, rather than just remaining some siloed, isolated initiative. Those structural indicators are what reveal the true maturation of a physical AI platform. So, what is the ultimate takeaway from today's explainer? It's this. The companies shaping physical AI are those capable of integrating technology, manufacturing, and operational learning into a continuously evolving ecosystem. The robot isn't the starting point, and it's certainly not the final destination. The robot is simply the highly visible result of decades of deep investment in compute, memory, and industrial infrastructure.
Which brilliantly leads us to our final, somewhat provocative thought for the day. Can Samsung successfully integrate its incredibly diverse, currently isolated technologies into a commercially viable physical AI ecosystem faster than its global rivals? They clearly have all the critical pieces of the puzzle. The strategic challenge now is pure orchestration. It is going to be a fascinating structural race to watch over the next few years. Thank you so much for joining me for this executive briefing. Keep analyzing, keep learning, and I will see you in the next explainer.